expression right here.
Okay.
Okay, pour 20 mils of potassium thiocyanate in a 50 milliliter graduated cylinder.
All right, so you're going to pour close to 20, and then you'll use the transfer pipette to get to 20. It's a qualitative assay, so it doesn't have to be perfect.
Well, did you have mine? Use this.
Why was it set at 23? 20?
Probably would have been easier to take.
Yeah.
One more.
Perfect. Pour it in here, put that off to the side, leaving the transfer pipette in it.
Just roll it.
Yep. Pour it into the Petri dish. Perfect. Just put it over to the right. The other thing I want to show you is the swirling motion. So with your fingers at the top, you can hold the paper with the other hand, and this is a swirl. So you may just want to take a minute to practice that. Don't overdo it because it'll splash. Good swirling. Okay, what's next?
And add 3 drops of iron 3 nitrate to different spots in the Petri dish.
So you're basically going to make like a triangle or 2 eyes and a nose, but you don't really want them near one another, so you don't have them touching initially. And then pour it back in there.
Hold on, we haven't taken it out yet. 1.9.
And you swirl it.
Swirl it.
You can put that down because it's going to roll off.
Alright, then add half a pea-size amount of potassium thiocyanate crystals in one spot.
And I have everything labeled for you. Keep in mind the size of a pea. That is not the correct bottle there. Make sure it says, there you go. So we're adding potassium thiocyanate.
What pea-size? Half a pea-size.
You do not want the scupula to touch the solution, so you'll get over it, and with your finger you'll tap you'll tilt it.
Exactly.
Yeah, you'll be over it, you'll tilt it, and then tap it with your finger. You don't want the scupula to touch the solution. You can do it. Turn it sideways. There you go. That's an awfully big pea. That's good. Exactly. Perfect.
And then swirl.
And note the
dissolve it.
color there, because you can see you're getting that blood red color indicating a shift in equilibrium in the forward direction.
Just swirl to dissolve it until it's a uniform color.
Do you remember what the temperature said? It probably dropped because of that. Oh yeah.
After that, add half a pea-sized amount of potassium nitrate crystals in another spot.
Different spot or just
Anyway. And really pay attention to this. It's a little hard to see at first glance, although if you actually look with your camera, it's almost a little more noticeable.
I'll just say 2.
Don't want to get too much.
Just leave it in for like a minute.
Oh, you throw it.
You can do it.
Like good.
Yeah. There's no wrong answer. It's good. Tap, tap.
Just
And then
swirl.
swirl it again.
Okay, so did you mention that it was rising?
Until it fully dissolves.
Yeah.
Alrighty. What's next?
And after that's completely dissolved, add a fourth of a pea-sized amount of sodium phosphate monobasic crystals.
Are one of you recording the colors you're getting? Yeah,
Yeah.
you'll, that's, okay, you're recording, good. Because that's very important.
Is that second salt like made a little bit lighter? Kind of works?
Yeah, a little bit lighter.
Is it a fourth pea size?
Yeah. After you pour it in, wait 60 seconds and...
That
just
one's
observe.
really making it lighter. The other one didn't really have much of an effect.
Just put it in.
Yeah.
Potassium
Put it
nitrate's
in
fully
60
soluble.
seconds.
Yeah, definitely. So mention that. Yeah, I said that the solids in clots.
And then after about 60 seconds...
That one you can
swirl it.
definitely see a lightening in the area. Now that substance is not in your balanced equation. So that substance must be reacting with one of the substances in your equilibrium reaction. Based on the fact it's sodium phosphate, it's not the sodium ion that's reacting with anything because that'll always be soluble. Well, you can see it clearing in the
Yeah,
area.
like that.
I don't know.
And just swirl it.
You guys are good swirlers.
Oh, that's correct.
That's crazy cool, huh?
Yeah.
Equilibrium shifts in the reverse direction.
Dr. Taylor, when we wash it, can we just wash it with this?
Add 1 drop of iron 3 nitrate in one spot off to the side. Don't stir it. Record its color change. After that.
1 drop off to the side.
Yes.
Dark.
There you go. That's that
It was
blood red color.
It was lighter.
Add 1 pea-sized amount of potassium thiocyanate crystals in a different spot. Record any changes.
Most of them.
No. Yeah, after.
Different spot.
Yeah.
How much a pea size?
1 pea-size.
It's all pumped up and now there's like nothing left.
Different spot.
Yeah.
It's just not together. Looks like it got like white or something.
Yeah.
It's weird.
We can go back and look at the tape.
Might put too much there, but
That's okay.
And then swirl the whole thing until it's uniform in color.
Think you're ready to rock. So that's introductory activity A. And now we're going to transfer the solution and get you ready for B so that you can look at the effective temperature
Awesome.
on the equilibrium reaction. All right, so let me show you how to pipette. Some of you are aware. When you pipette, the best thing to do is to squeeze the bulb There may be a little solution left over here because we didn't get clean pipettes. It's okay, just shoot it out on the paper towel or in the sink. When you go to pipette, you want to tilt the Petri dish towards you, put the tip in, and you will press up. You want to really watch. You don't want to go past the -1 because you don't want to take a chance that the liquid will get caught up into the filter, because then the filters have to be changed and they're expensive. So I usually go, I'll help you in a sec, usually go up and down twice to mix it. And then it says 10 mils into each test tube, although we only started with 20, so we're just going to do 9.5 in each, and it's not quantitative, it's qualitative. Can I have test tube A, please? Thank you. The key here is when you go into the tube, make sure you press down to deliver. If you press up, you will suck up the solution into the filter. And then you'll just do the same thing here. And your next lab actually requires, I'm going to re-squeeze this, your next lab actually requires a lot of pipetting, so we'll be pipetting with water initially until you feel very comfortable with this technique. Don't hold it upside down. Thank you. Down to deliver. Did you use these last year?
No.
Okay, I'll help you. All right. Now you have 2 tubes filled with about 9.5 mils. There's a little left over, but it really doesn't matter. And now you're ready to look at the effective temperature on your equilibrium reaction.